Okay, so part 2 is the composition of functions, f of g of x, or it's written as f of g of x, where g of x is replacing the x of f of x. And a side note, the composition f of g of x inherits the most restricted domain. So whatever restrictions you have on domains of the two that you start with, you have to restrict your domain that much. So given that f of x is x squared plus 1 and g of x is x minus 4, find f of g of x. I prefer the other notation. I feel like it shows you what you're doing more. So I'm going to change this notation first into f of g of x, because I prefer to work with that one. And since I'm starting with the f, when I read the notation, it tells you what you're doing. Since I started with f, I'm going to go to the f function. And I'm going to start writing the f function. But anytime I get to an x, I'm going to leave a blank. So if this case, there's only a single x. If there were multiple x's in the function, then every time I got to the x, I would leave a blank. So the f function, but with blanks for x's. So blank has to be kind of big because you're going to put your other function in it. So blank squared plus 1. That is the f function, but I just left a blank where the x was. And as the notation shows, g of x is inside the f function. So I'm going to now take my g of x and I'm going to fill in the blank with g of x. It's x minus 4, so I'm putting in x minus 4. If there were multiple x's, there would be multiple blanks, and I would fill in g of x, the x minus 4, into every single one of those blanks. In this case, I only had one x. Then I need to simplify this. So I have x minus 4 is squared. So I need to FOIL x minus 4. So I'm going to write this as, I'm just going to write it next to each other. So x minus 4 times x minus 4, and then plus 1, because don't forget about the plus 1. So if I FOIL this, it's first is x squared. Outside gives me a negative 4x. Inside gives me a negative 4x. And the last two terms multiplied together gives me a positive 16. And then don't forget there's this minus 1 on the outside, or a plus 1 on the outside. I have these like terms in the middle, and I have like terms on the end. So this is x squared minus 8x plus 17. That is my composition. F of g of x is x squared minus 8x plus 17. All right, number 2, g of f of x.
Do we have to use the domain for this?
Not for these. We're going to do one with the domain at the end. G of f of x. So this one starts with g. If it helps to rewrite it into the other notation, then go ahead and do that. Or if this one's fine with you, then it still shows you what you're doing. It starts with g. G is the first letter. So that tells me I'm going to go to the g function first. My g function is x minus 4. Everywhere there's an x, I'm going to leave a blank. So this is going to be a blank minus 4. That is my g function, but I'm not writing an x. And then I look back at my notation as g of f. That tells me the next function I'm going to look at is the f function, which is x squared plus 1, and that's going to go in to all of the blanks. I only have one blank. So x squared plus 1. That was the f function, and I put it inside the g function. And then I simplify. So I have parentheses x squared plus 1, and then a minus 4. So these parentheses aren't really doing anything as far as operations are concerned. So I'm just going to ignore them, drop them, get rid of them, however you want to phrase that. So I have x squared plus 1 minus 4. So this is x squared minus 3. That's it. So the order that you work with your functions, f of g or g of f, it was the same two functions, but not in the same order, gave you very different compositions. Then we do number 3. Is f of g of 2. F of g of 2. Well, we've already done the composition f of g of x, right? That's what we did right here. Do that. Since we already did f of g of x, and now it's asking for f of g of 2, I'm going to take what I got for f of g, which was x squared minus 8x plus 17. That's my f of g of x, but now I want it to be of 2. So everywhere that there's an x, so this one was of x, everywhere there was an x, I'm going to turn it into a 2. So this is, instead of an x, blank squared minus 8 blank plus 17. And I'm going to fill in 2's for x. I'm evaluating for when x is 2. So I get 2 squared is 4. Negative 8 times 2 is negative 16 plus 17. So this gives me 5. So when you evaluate a composition, you just end up with a numerical answer value. One more. So then compositions part B is given. This time we're going to have f of x equals 1 over x plus 1. And we're going to have g of x be x squared minus 9. So our new f of x and new g of x. Find f of g of x and its domain. Because we need practice working with domain. All right, so we're doing f of g of x. So that tells me I am starting with the f function because my first letter is f. So I go to my f function. 1 on top, there's my x, there's my blank on the bottom, plus 1. And then I'm going to fill in my blank with the g of x, which is x squared minus 9. So I put the g function inside the f function. And then I want to simplify it. In this case, the parentheses aren't doing anything. It says x squared minus 9 and then a plus 1. So this is 1 over x squared minus 8. And that is the composition. And then I have to find its domain. So when finding the domain of a composition, it inherits the most restricted domain. So we have to look at all the domains, plus the domain, since we have a rational, we have a denominator, we also have to look at that. So the domain of f so we look at f of x. It's a rational function. So we know the denominator cannot equal 0. So what would make this denominator equal 0? A negative 1. If we plugged in negative 1, we'd have negative 1 plus 1, which equals 0. So the domain for this function is all real numbers, but x cannot equal negative 1. That's the domain for f of x. And then we look at the domain of g of x. It's x squared minus 9. What is the domain? What is the domain of x squared minus 9? All real numbers. It's just a quadratic. No restrictions. And then we also have to look at the new denominator. That cannot equal 0. So domain, whatever. So this cannot equal 0 for the new denominator. X squared minus 8 equal to 0. So we can find out what value that would be. Add the 8, so then x squared equals 8. We take the square root, then x equals plus or minus. I'm going to go ahead and write square root of 8, but this is something you might as well just memorize now because you're going to write it about 1,000,000 times this year. That the x equals plus or minus 2 square root 2. That is square root 8. Simplified. If you want to simplify it every time, that's fine, but you're going to write that number a lot. So just 2 square root 2. That is the square root of 8. So this is, or I guess we could say x cannot equal those values, because that's what makes this denominator equal to 0, and we can't have that. So then the domain of f of g of x, then it's any and all restrictions. So g of x doesn't restrict us at all, just all real numbers. F of x restricts us, and the new domain restricts us. So all real numbers, but x cannot equal negative 1 or plus or minus 2 square root 2. That's the new domain. And 18, 25 through 28, and 56. And this is the assignment for 1-6.